Prove that if two sides of one triangle are congruent to two sides of another triangle, then the included angle of the first triangle is larger than the included angle of the second. Then the third side of the first triangle is longer than the third side of the second. This is the famous Hinge theorem. Look at the two triangles in the diagram. They are ABC and DEF. Side AB is congruent to side DE. Side AC is congruent to side DF, and angle BAC, that is this angle, let us call it theta, is greater than angle EDF, that is this angle, let us call it alpha. So theta is greater than alpha. We have to prove that BC is greater than EF. Draw a triangle AGC as shown, such that triangle AGC is congruent to triangle DEF. That is AGC, this triangle is congruent to DEF. Both the triangles have been shaded green. We can draw such a triangle by drawing an arc with radius DE and with center at A. That means we draw an arc like this, and another arc with radius FE, that is FE, with center at C. So we draw another arc like this. If the two arcs intersect at point G, then draw lines AG and CG. So, because of our construction, AG is equal to DE, GC is equal to EF, and already we know it is given in the problem that AC is equal to DF, which is the common side. Therefore, triangle AGC is congruent to triangle DEF by side-side-side congruency. In the new triangle drawn AGC, since AGC is equal to or congruent to DEF, these two angles will be same. These two angles will be alpha or will be equal. To start with, angle BAC, that is theta, was larger than angle EDF. So, after theta is taken out from angle BAC, some more angle will be left. That is theta minus alpha. It is angle BAG. Bisect this angle. Let the bisector meet BC at M. Then triangle BAM and GAM are congruent because of SAS, that is side angle side. Which are the sides equal? AB is equal to AG, AB is equal to AG. We have taken it by construction in the previous drawing. AM is congruent to itself, or which is common, and angle BAM is equal to angle GAM because we have bisected this angle BAG. Since we have just now proved that triangle BAM is congruent to triangle GAM, we get BM is equal to MG. Now in any triangle, sum of any two sides is greater than the third side. So in the triangle CMG, that is CMG, the triangle has been shaded blue, CM plus MG is greater than the third side CG. Now MG is equal to PM because the two triangles are congruent and this side MB is equal to MG. Hence, CM plus MB is greater than CG. Now, CM plus MB is equal to BC. That is CM plus MB is equal to BC, total length of the side. And CG is equal to EF. CG is equal to EF. We have taken it during construction of this side. Therefore, we have BC greater than EF because CB is greater than CG and CG is equal to EF. So the whole side is greater than EF. This is what we are required to show.